manufacturing and the history of the Energia space program, specifically the Buran space shuttle, is very important to understanding what this space program is as a whole, because it was very unique from a lot of the other rockets of the time. So under the lead of Roscosmos, the new space organization of the newly formed Russian Federation, and SP Korolev's Energia company, this rocket will be produced after years of design. In fact, almost 15 years of design. So what's different about the Energia program and the Buran rocket space shuttle is that it uses liquid fuel instead of the old solid fuel engines, and it uses a brand new propulsion system that was initially conceptualized by famous Soviet astronomer and engineer Valentin Glushko. Valentin Glushko was a famous Soviet engineer who was incapacitated by figures such as Jules Verne and Konstantin Tsiolkovsky. He earned his degrees in Odessa, Ukraine, and worked with explosives and fuel and hydraulics plants. He did become caught up in Stalin's Great Purge and was sent to Butrika prison in Siberia. While in Butrika prison, Glushko was working on various projects with other arrested scientists, specifically Korolev, to design the liquid-fueled rocket engines. They designed the RD-1 Hertz auxiliary rocket motor. During his career, Glushko worked on programs such as the R7 Semyorka project, but ultimately his ideas of propulsion and fuel lead him to creating the Energia program as we know it. Although Glushko would pass away in 1989, he did elect an heir to his throne, that being Ukrainian-Russian astronomer and engineer Gleb Lozino-Lozinsky. Lozino-Lozinsky was the head designer and engineer on the program of Energia Buran. Lozino-Lozinsky often led top-secret Russian space projects and was put in charge of NPO Molniya in 1976, where from there forth he would take over the Buran project after Glushko's death. To understand the scale and size of the Energia Buran project, you have to understand the sheer economic standpoint that it comes from. This project was by far the most ambitious Soviet and Russian shuttle program ever seen. It ended up costing just over 16.4 billion rubles in 1992, which is the 1992 equivalent of 121 million US dollars. The assembly of the Buran program specifically started in 1980, and the fuselage delivery was delivered to NPO Energia in 1983. But it is unknown exactly where this manufacturing was committed. In 1984, the parts were delivered to Baikonur Cosmodrome in Kazakhstan, where the final construction and assembly began. After years of construction, it finally began its first flight in 1988 and continued after that. The failure of this space program was a devastating blow to the newly formed Russian Republic and the following consequences it would have underfoot in the space race.
Energia Buran had many different test flights. From 1985 to 1988, they had 24 flights. There were 9 missions that had been canceled between 1991 and 1995. There was only one successful launch and orbit flight on November 15, 1998. The Energia Buran was created to launch the Soviet Buran reusable shuttle. They made the payload on the side of the stack, which is unusual because usually they make it on the top. The Energia Buran is able to be customized for many different payloads because there are 2 to 8 booster stages. The booster stages are around core-equipped modular main engines. The boosters are powered by 4-chamber burning engines. The specific payload was the Buran-class orbiters in the source of the orbit insertion impulse. There are a few military reasons and purposes for Energia Buran, one of them being to enhance pride in the Soviet Space Agency. It would look very good if they were able to pull off the orbit because they would be technologically advanced. The Soviets were still in a race against the US and trying to accomplish more and higher up. Another reason for the military use was for information. They wanted to learn more about space and retain as much knowledge as they could. Also, for the return of Earth and miscellaneous loads. Another reason was to help the resupply of the Mir space station. They also intended to continue to work on the Engineer Buran in hopes of helping deliver weapons and other military devices. They wanted to use Buran as a way of defense. The Soyuz R-7 are military orbital carrier rockets and have been used for all Soviet and Russian human space flights. There are 3 versions of this that had medium to heavy payloads. The purpose of the R-7 was launching satellites, probes, manned and unmanned spacecrafts, and other non-threatening payloads. The Apollo 11 command module Columbia was the first rocket to take the man to the moon. The mission was to gain technological advances against other countries and find research about the moon. The aircraft was very particular and precisely made, and resembled the shape of Mercury and Gemini spacecraft. It had heat shields over the aircraft while re-entering Earth. Some of the pieces of the aircraft would burn off because of the temperatures. The purpose of the lunar robotic exploration is exploration of Mars and other parts of the solar system. The orbital module is the Maxar-built power propulsion element. This is in order to make the ability to keep its orbit. In a weird way, Buran was seen as sophisticated, spectacular failure and impressive technological accomplishments. By the Russians who worked on it, the sole purpose of the Buran was to simply keep up with Americans due to their new NASA space shuttle program. And all of it was basically did lift the shuttle. Engineer Buran was created to increase the respect for the Soviet space age. Engineer Buran didn't have a huge amount of influence in the space race due to its purpose only lifting the shuttle. It would never actually be able to land on the moon. That said, it was found fascinating because it was reportedly was heavy enough to lift more weight into space than any rocket yet developed. Although Engineer Buran had a lot of potential, it didn't play a huge role in the Cold War. Because of its ability to hold large amounts of cargo, it had to drop its engine. This made the Buran expensive and unable to reuse, unlike the US that had reusable but could hold as much cargo. Buran's program ended up falling through during the fall of the Soviet Union due to lack of funds, but the Russian scientists that worked on it believed it could have been something amazing. Buran had military significance because it was automated flight system. This means that it was able to launch, orbit, and return without any crew members on board. This is huge military because it could be used for rescues. In the Soviet Union, if the Soviet Union didn't collapse, there could have been a lot more economic significance it had.
Member of a family of Russian heavy-class launch vehicles that was abandoned in 1990 after only 2 launches. At the time of development, the Soviet Union had had no experience in the production of large solid rocket motors, especially segmented solid rocket motors of the type used on the shuttle. Glushko, the Soviet engineer who designed the engine, preferred a launch vehicle with parallel liquid propellant boosters. Because of this, the final decision was to use familiar LOX kerosene liquid propellants for the boosters. The modular Energia design could be used for payloads from 10 to 200 tons using various combinations of booster stages, numbers of modular main engines in the core stage and upper stages. The mass at liftoff ended up being 2,400 tons. The launches occurred at Baikonur Cosmodrome, a site that is spread over many kilometers across Kazakh grasslands. The launch facilities for the Energia Buran system included a single complex for testing and launching the Super Heavy Energia booster and a dual complex for manned Energia Buran missions. As mentioned previously, there were only 2 launches of Energia Buran, only one of which was successful. The first flight occurred May 15, 1987, and the second and last flight occurred on November 15, 1988. There are a few notable aspects of Energia Buran, and the team working on it encountered many challenges while designing and testing the spacecraft. One notable aspect of the design is that Energia Buran was built to be a reusable shuttle. This is important because the first reusable spacecraft, the American Space Shuttle, was launched just 6 years before. The most unique feature on the spacecraft is that it was designed to carry its payload mounted on the side of the stack rather than on the top, as is done with other launch vehicles. After some testing and redesigns for efficiency, the main engine stayed in the core of the vehicle and was consistent with other designs of the time. The liquid boosters were kept, but were lessened to only 4. After being re-stressed for the lateral launch loads, the newly improved Energia launch vehicle had half the liftoff mass and payload of the Vulcan. This was enough to carry the Buran with its required internal payload of 30 tons. One of the issues that the engineers faced when carrying out tests and launches was the ground handling. The engineers didn't know how to move the vehicle after it had landed, especially if it landed outside the normal landing zone. The final analysis of the problems pointed that the most reasonable solution was an orbital of the aircraft type. There was a lot of backlash that occurred because of the decision to copy the American Space Shuttle configuration, but earlier studies had considered the many types of aircraft layouts, vertical takeoff designs, and ground and sea launch variants, and the Energia engineers could not find any configuration that was objectively better. They realized there was no point in picking a different or worse solution just because it was original. There were also many issues with the mechanics of the Buran, which resulted in delayed tests and even left Leninsk without water for 10 days. The final unique aspect of the Energia Buran is that it is responsible for the first operational use of superchilled hydrogen.
Most people are not aware that Buran existed, let alone its very impressive capabilities. Common article titles often imply or outright claim that the Soviet Union stole the plans for the space shuttle to create Buran. This is not true, as much of the space shuttle program was published openly, and the Buran made some significant changes to the overall design. A factual assessment would be that the Soviet Union iterated an improved version of the space shuttle in the Buran program. Energia only receives attention or discussion within academic circles. The Buran spacecraft and Energia launch vehicle have had very limited cultural impact. As was the norm with Soviet-era programs, the shuttle and launch system were developed in secrecy, though the programs were massive in terms of number of firms involved and staffing. The single orbital and unmanned launch was the only proper space flight the craft made. This was simply not enough to enter the cultural zeitgeist at a time dominated by so many other events. Some major events that occurred in the Soviet Union in 1988 were the visit of Ronald Reagan, the official adoption of perestroika by the Presidium of the Supreme Soviet, major strikes and protests in Georgia, and just a few years later the Soviet Union itself fell apart. Buran could not compete with these events in the minds of the common man. An attempt was made to make the Buran relevant in people's minds. Stamps were issued and art was created. The Soviet Union wanted to use the Buran to have the first female cosmonaut complete a spacewalk. A stamp was pre-designed to commemorate this future event, though it did not occur. The Burans and Energia system were housed at Baikonur, which was within Kazakhstan post-collapse. Though the Russian government leased control of Baikonur shortly after, there was not enough money or political interest to keep the Buran program going. In 2002, complete neglect finally caught up to the Buran. The rusted-out hangar collapsed and destroyed both the Buran orbiter and the Energia launch system. The remaining test platforms and partially completed orbiters exist in various states of disrepair and neglect at Baikonur today. The AN-225 was designed to be the carrier craft for the Burans. Sadly, the only completed AN-225 was recently destroyed in the Russo-Ukrainian War. This adds additional need to use the past tense when discussing the Buran program's development. Thankfully, the completed Buran, which is used for atmospheric flight testing, still exists. The Technique Museum Spire houses the OKGLI in a completely preserved state, which can be seen by the public today.